Let's do some review with naming acids. We had a little bit of a difficulty on that, so I want to make sure that you understand what you're doing. There's two types of acids. There's binary acids and there's oxyacids. So let's take and dig into this a little bit. First off, how do we know the compound is an acid? Well, we're going to know by looking at the chemical formula that there's an H that precedes the formula. Obviously, if you see the written word, you're going to see the word acid. So that's the easy part. So if the formula begins with an H, here are some examples. We have H with fluorine, H with chlorine, all the way down to an H with a sulfate ion. How do we know if the acid is binary or oxyacid? A binary acid, the hydrogen is just with one other element. Remember, bi means two, so therefore you have two total elements in your compound. So we have hydrogen with fluorine, hydrogen with sulfur, hydrogen with bromine, and hydrogen with phosphorus. An oxyacid, the hydrogen is going to be with more than one other element, and that more than one other element's probably going to be a polyatomic ion. So therefore, if you look at the bottom, we have hydrogen with sulfite, hydrogen with phosphate, and hydrogen with nitrate. So that gives you an indication an oxyacid is going to have an oxygen in there with the polyatomic, but it's also going to have three or more elements within the compound. So when we name binary acids, what we do is we start with the prefix hydro. Then we use the root of the second element, add the suffix ic, and then we write the word acid. So let's look at an example here. We have HF. So we use hydro. F is fluorine, so we use fluor, the root of the second element. We add ic, the suffix ic, and then we say acid, hydrofluoric acid. HI, we have it with iodine, so we say hydro. Iotic, I know that sounds really weird. Iotic, we use the ic, and we say acid. If we have it with nitrogen and hydrogen with the nitrogen, we say hydro, and then we say nitric acid. When we write the formula of a binary acid, we're going to use the same rules as ionic compounds. We're going to use the charges. So the charge on hydrogen is always going to be a +1 in an acidic situation. So for example, if we're looking to write out the chemical formula for hydrophosphoric acid, we see that the prefix hydro is there. So we're going to know that this is a binary acid. So we have an H with just a phosphorus because it is binary with the hydro there. That gives us an indication. An H has a +1 charge. Phosphorus, according to our periodic table, has a 3- charge. So we're going to crisscross just like we do in ionic, and we'll end up with H3P. Let's look at another example. We have hydroiodic acid. Again, we see the prefix hydro. We know that it's going to be a binary acid. So we have H is with iodine. So H has a 1+ charge, iodine has a 1- charge. We're going to crisscross just like we do with ionic charges, and we get HI. When we write the chemical formula of an oxyacid, we're going to do things a little bit differently. So in this case, we do not have a hydro prefix. Instead, we are going to check the polyatomic ion. If the ending ends in an 8, so if the polyatomic ends in 8, like phosphate, sulfate, chlorate, then ic becomes the end on the acid. If the ending is ite, like sulfite, nitrite, chlorite on the polyatomic, then us, OUS, becomes the ending on the acid. So for example, let's look at phosphoric acid. We realize that there's no hydro there. So therefore, we know we have to look for a polyatomic, and the ending is ic. So we must be coming from phosphate. So therefore, we have an H with a +1 charge. Phosphate is PO4 with a 3- charge. Notice that 3- charge is on the whole phosphate ion. It's not just on the oxygen. When we crisscross, just like ionic, we're going to have that 3. We're going to bring down that 3. And of course, we don't write that 1 when we bring down the 1 on the outside of the phosphate. Let's check another one. Sulfurous acid. So we have H +1, because it ends in OUS, It comes from ite. Ite is sulfite, SO3, with a 2- charge. A lot of times I remember these ites go with us and ates go with ick. The way that I like to remember it is I ate Brussels sprouts and it was ick. So you can insert whatever you don't like in there. We're going to crisscross like ionic charges, and so we'll get an H2SO3. We want to keep the whole SO3 intact, just like a polyatomic. Let's look at a comparison of binary and oxyacid formula just so you can see them all together. I like to compare 3 different formulas so you see the full written comparisons here. First off, we have H3N, HNO2, and HNO3. So H3N is going to be a binary acid because it's just a hydrogen with one other element. When we have that binary acid, we are going to use the hydro. So we say hydronitric acid. We use the hydro and we still use ic on the ending. With HNO2, we realize it must be an oxyacid because H is with a polyatomic, and that polyatomic is nitrite. So the ending must be us, O-U-S. We're not using the prefix hydro. So instead, we're just going to have nitrous acid. And finally, the last one, we have hydrogen with a polyatomic, and that ion is nitrate, so the ending is ic, I-C. So therefore, we're not going to use the hydro again, and we'll just have nitric acid. This is some information that can help you guys. The biggest thing is you have to practice. So be sure to ask me if you need some extra practice stuff, and let's go for it. See you guys later.